That's totally fine. All right, so we're gonna talk about WDAC for the Applocker admin, or the reason why this session is we often hear that Applocker is easier to implement than WDAC. And that might be true, but you're not playing by the same rules. The reason why in most scenarios Applocker is easier is because you don't enforce the same settings that WDAC does by default. So we set out on a mission to implement WDAC following those same Applocker rules, and that's what this session is a bit about. The problem with that scenario is that each time you do that, that has some influence on your security level, or on the level of protection that WDAC and Applocker brings you. So this whole slide deck is here to show you the differences between the two, or the analogies between the two, and what the impact is on your environment. So normally I would do this session with my esteemed colleague Kim Oppalfens, who misjudged his calendar. Which means that I'll be doing this for you guys alone, but that's fine. It's a Friday morning. What can go wrong, right? So let's take it away. We're gonna talk about how we actually measured the effectiveness of WDAC or Applocker. Since you want to compare the two, it means that you need a way of measuring the impact of the two scenarios. We're gonna then talk about what a minimal Applocker implementation look like, how we can mimic that in WDAC, and then finally, if you are convinced that WDAC is the way forward, we'll show you some tools how to migrate one to the other and what additional benefits WDAC will still bring to the table that Applocker doesn't. As a quick way in between, both are application allow listing technologies, right? The goal is that you control which applications are allowed to run on your end users' workstations. In that scenario, it means that all the malware, which you obviously did not explicitly allow to run by default, does not run. So both tools are geared towards raising your security posture drastically. With a big difference is that Applocker is, I'd say, no longer supported, but that's not 100% correct. It's no longer maintained and serviced, and is actually built as a compliance tool, not as a security tool. So that means that if you find a bug in Applocker or bypass, they may or may not fix it for you. WDAC has been built strictly as a security tool and is still serviced, and there are bounties. So if you find a bypass for WDAC, you'll report it, they'll fix it, and you might or might not receive some money or feedback on that scenario. So that's a big difference between the two. So let's talk first about how we try to measure the effectiveness between the effectiveness of the two technologies. And we started out by creating a huge Excel sheet that are based on the Defender for Endpoint Analyst threat campaigns. So I assume most of you are familiar with Defender for Endpoint portal. In there, you have each month a set of threat campaigns, or well, threats that came out that month that were analyzed by Microsoft employees and explaining them exactly what that specific threat did, how effective it was, what technologies it used, and so on. So we took each of those threat campaigns, I think, I'll have to look it up, but at least going back to somewhere 2022 up until a few months ago. I think we still have to do it for the last 2 or 3 months. We've been busy with other things in the meantime. So we took each of those threat campaigns and poured them into this Excel that you can see a snippet up front here. And then we tried to analyze and see if that threat campaign would be allowed to run or would be blocked to run on each of the different scenarios. And the scenarios you can see here is the default Applocker exe rule set, Applocker and DLL enforcement enforced, Applocker, DLL, and scripts enforced, and then the other way around by a default WDAC implementation, WDAC with Applocker, default Applocker path rules, and so on. So we took each of those scenarios, and we then try to give it a score, and that score then allowed us to measure the effectiveness of each of those different scenarios. So if you would go to your Defender for Endpoint, you often get these. Well, this is a very nice scenario, but they give you sometimes a drawing, sometimes it's text, and then we started out by validating that and trying to understand what exactly was happening, and then see the impact on each of those scenarios that I've just shown you. You'll see that roughly halfway in the slide here. Can I show that? Here you see a hands-on keyboard activities. That means that at that point in time, basically the device is compromised, and that's where we stop our analysis. Once you get hands-on keyboard, whether it's physically or remote, a lot of the implementations of any security measure basically is out of the window in the hands of a skilled hacker. So the goal was to check whether you would actually get to the hands-on keyboard scenario. Okay. And so that brings us to exactly, I've quickly touched on that already in the previous slide, but that brings us to exactly what we are measuring. At the left hand, you'll see the default, or you'll see the Applocker side. The right hand is the WDAC side. And basically, what we see a lot in the field is that a default Applocker implementation includes the 3 Applocker path rules. So Applocker by default, if you enable it, will create a path rule for everything allowed to run in program files, everything allowed to run in program files x86, and everything allowed to run in the Windows folder. Without those 3 path rules, Applocker doesn't even work properly. So those are there by default. And then they enforce executables. So only trusted executables will be allowed to run. That's the implementation we actually see the most. A bit more severe is if you add in script blocking. That means that untrusted scripts, most of the time PowerShell, are not allowed to run. The way around that would be to sign your own PowerShell scripts. Obviously, the bad guys don't have signed PowerShell scripts, or at least not signed by a certificate trusted by you. So those would not be allowed to run. In your scenario, they would be allowed to run. But so that's not an implementation we see that often. Even more strict would be then to allow DLL enforcement. So a lot of all the malware campaigns out there, they don't actually use executables anymore. They use either scripts and no things written to disk, or DLLs. And a default Applocker implementation hardly ever blocks DLL. For somewhat, well, I'd say skilled hacker, but that's not even the case. For somebody who is a little bit tech savvy, doesn't need an exe to run any executable code on your machine. You can fairly easily compile the code that you need into a DLL and then run whatever you need to do out of that DLL. So again, that will be a bypass in the Applocker scenario. And then obviously the biggest blocking scenario in Applocker would be enforcing all of these together. So default Applocker rules, enforce scripts, and enforce DLL. So each of the rule options you enable gives you more security in an Applocker scenario. If we look at the WDAG side, so the right-hand side of the slide, is actually the inverse. A default WDAG scenario or a default WDAG implementation, either by doing it through Config Manager or Intune, or even doing the wizard that I'll show later, basically starts where Applocker ends, which means that everything in Windows is trusted. There are no path rules there. So everything in Windows is trusted, Office is trusted, Teams is trusted, and that's about it. So DLLs are blocked by default, or untrusted DLLs are blocked by default, XAs are blocked by default, and scripts will run in constrained language mode, which means that to fully allow PowerShell scripts, you'd have to sign them. So in order to mimic the Applocker implementation, we then weakened our WDAG policy by allowing the program files path rules. The next step would be allowing program files and Windows path rules. Keep in mind, Applocker needs the Windows path rules to run. WDAG doesn't. It has a whole different way of ensuring trust in or making sure that Windows is allowed to run. And then we disabled script enforcement, and then finally it's everything together. So that brings us more or less, that gives us more or less the same playground than Applocker, so we would be able to compare both scenarios. So as a recap, a default or a minimal Applocker implementation enforces executables, has the default path rules for program files, x86, and Windows, and has by default an admin bypass. So by default, if you are in the administrator group, you're allowed to run everything. It's only enforced for end users. The other way around, if we check the WDAG default implementation, it enforces the same XAs. It doesn't allow admins, so there is no bypass for admins in WDAG, and there is no way to actually create it. Either an application is trusted or it's not. So admins are not allowed to. There is no way for you to say that a certain group of users is allowed to bypass that. There are no default path rules. And it includes script enforcement and DLL rules. So that's the starting scenario for both. Now, with a default WDAG implementation, you actually get a 93% coverage of all of the analyzed Defender for endpoint threat campaigns. So if you go back a few slides where I explained that we analyzed all of the Defender for endpoint threat campaigns. Using these rules here, a default WDAG implementation would stop by default 93% of all of the Defender for endpoint threat campaigns. We've had some feedback in the past saying, why 93%? Why not 100%? Why is not everything stopped? I'll have a slide at the end if we get there that explains why we don't get to 100%. But it's not up to WDAG. That's a bit of the preview here. So again, 93% of all of the threat campaigns are blocked by a default WDAG implementation, which actually gives you a lot of peace of mind, right? It means that whenever a new threat campaign is out there, the chances are very, very high that you're already protected, which means that you can probably sit back take some time to analyze the report, and then most of the time decide, hey, I'm good, I'm safe. There's not much I need to do. I'm not going to be affected by this specific threat campaign. Where in the other scenario, in an Applocker scenario, or if you don't have any of the two implemented, each of those threat campaigns that are out there, keep in mind, remember Print Nightmare, remember Serious Sam, Petit Potam. There's a few out there from a few years ago that caused some serious nightmares for IT admins. So for each of those threat campaigns that came out, you'd have to start analyzing, am I infected or am I affected? Sorry. Is this something I need to do? What can I do? Like for the printer nightmare, there was not a whole lot you could do until Microsoft fixed it. And then it took them quite some time to actually fix it. So the mindset and the peace of mind you get by having a WDAC implementation is a whole lot greater than in the other scenarios. So how do you do that? How do you start by implementing WDAC? You could go hardcore and code the XML yourself, or you could use a tool created by Microsoft called the Windows Defender App Control Wizard. I assume you guys can see my screen where I now have the App Control Wizard on there, right? Okay. So whenever you launch the App Control Wizard, you can basically go and say, hey, I want to create a policy. I want to create a base policy. I'm not going to explain every single option in here, since that will bring us way beyond my allowed time here. And then I can choose a scenario. I can choose to have the default Windows mode, which is the one that we basically start with, which trusts the OS, the store, Office, OneDrive, and Teams, and it enforces that the drivers are Windows Quality Lab signed. You could go further or weakening more your policy and say, I allow everything signed by Microsoft. And you could go by something says signed and reputable mode, which uses some internet security gateway and queries whether an application has a good mode, and that would be allowed to run. Everything else would not be allowed to run. In most of the implementations we always start in the most strict mode, so just the OS, store, Windows, Office, OneDrive, and Teams. So that's basically how you start. You then choose the options that you want to apply. Do you want to start in audit mode? Most of the time, that's what you want to do. And then if I would finish the wizard, next, done, I would have a WDAC policy that I can start implementing. So that's a fairly nice UI compared to even the Applocker UI to get you started with WDAC. We'll use this later on to show you how we can then mimic the Applocker implementation. So the first thing we're going to do is talking about path rules. So talking about path rules. So a default Applocker implementation, as I already mentioned, has 3 path rules, which means there is one for program files, x86, and Windows. WDAC has the same. So you can add path rules in WDAC. They're not needed, but you can. If you want to make everything in program files trusted, that's fine. Same as for Applocker, you can use wildcards at the beginning at the path or at the end of a path. Since Windows 11, you can actually have multiple wildcards in one rule. Word of advice here: don't add a wildcard at the beginning of your path, since that would mean that every file that I can then mimic would become trusted. Having a wildcard at the end of a path in most scenarios is fine, with the condition that the path should not exist, that the path should already exist. Do not create path rules for paths that might not exist on your end users' workstations. A big difference between WDAC and Applocker path rules is the fact that if an Applocker path rule is set, and I, as an end user, have permissions to write in that specific folder, I can put in the files that I want there, and they would be allowed to run. For WDAC, that's not the case. If I, as an end user, have write permissions in the path, then the path rule would actually not apply. So that gives you a little bit more peace of mind with creating path rules that once an end user is allowed to run in to write files in it, they would still be blocked from execution. So that's a big difference between the two. And then the warning: do not create path rules for non-existing paths, because if I create a path rule for ctemp and that would not exist yet, I, as an end user, am allowed to create that path at that point in time, which means I get full permissions on that specific path. It equally means that I have user writable permissions, so I would not be allowed to execute those binaries that I would put in ctemp. However, since I have full permissions, I can then put in the files in that specific path, then remove my own write permissions, and I would then at that point in time be allowed to run those binaries. If I need to add more, I add my write permissions again, copy in the new binaries, remove my write permissions again, and those binaries would be allowed to run. So word of advice, same goes for Applocker, obviously. Do not create path rules for rules that for paths that do not exist. So what does that mean for WDAC wizard? How do we create a path rule? We add a custom rule. That brings us to the next screen. In user mode, so we're using mode, we want an allow rule, we want a path rule for a specific folder, and then we browse to the path that we want to add files, create rule, add file 686. Create rule. Now, by doing that, actually not much changes between the two scenarios. So if we would compare the effectiveness of WDAC and Applocker by adding those two program file 686 rules, we actually notice that none of the current threat campaigns would be allowed to run. So we would still be at a 93% effectiveness for that scenario. And then if we would then add one for Windows, the things changes a little bit. Windows, create rule. We then drop to 90% effectiveness. So there are some threat campaigns out there that abuse the Windows folder, and Print Nightmare was actually one of those campaigns, right? It allowed end users to create a malicious DLL into the spooler folder, and people would be able to abuse that malicious DLL. So adding a Windows path rule does lower your WDAC policy effectiveness. All right. That brings us to the next scenario, script rules. And that's probably one for us as IT admins is the most challenging, since we rely heavily on scripts, PowerShell scripts. So what does that mean? First of all, we have to be aware that not all types of scripts are going to be affected by WDAC. That's why we have these enlightened hosts as our initial point. PowerShell script, VB script, C script, and JavaScript are all enlightened hosts, which means they all will have to follow the rules in WDAG. So they would be blocked by default, or at least run in constrained language mode for PowerShell, which allows you to do only basic things in PowerShell, unless you sign the scripts, and then they will run in full language mode, and you can again do whatever you want. Uncontrolled hosts are command.exe. Our command prompt is not enforced in WDAG. You can do whatever you want in your command prompt. Most of the time, that would be allowed to, you would use that command prompt to launch an executable, which then again is affected by WDAG. But the command prompt by itself, any command you can run in there, would be allowed to run. Python is another one of those interesting hosts. We've actually played around with it, and I think it took us roughly 10 lines of Python code to encrypt every file in your My Documents folder. However, if you allow Python to run, all bets are off, since Python does not play in the WDAG space. Same goes for JavaScript. If you have third-party JavaScript engines, there's not much we can do. And then you have something called a custom PowerShell host. You can actually create your own PowerShell host if you would want to do that. And if you create your own PowerShell host, you define the rules that PowerShell host need to apply to. So you just don't add the WDAG part to that, which means that you can do whatever you want. And the last one is PowerShell v2. So PowerShell v2 is also not aware of WDAG, so anything in PowerShell v2 is allowed to run. If you still have PowerShell v2 on any of your devices, by all means, go ahead and remove it. There is no good reason anymore to do that or to have that. It doesn't have any logging capabilities, doesn't have any WDAG capabilities, so you'll be running blind. And a lot of the malware will actually test to see if they still find PowerShell v2 on the machine, and would then launch their scripts in PowerShell v2 mode. So that would evade everything at that point in time. Do notice that if you enable WDAG, even in audit mode, that MS-HTA and MS-XML scripts will always be blocked, even in audit mode. So MS-HTA and MS-XMLs are old script hosts, fairly unsafe. Most of the time, you probably don't have any tools anymore that use or abuse that, but they would be blocked even in something called audit mode. So there's not much you can do there. There is no way to make those trusted. The only thing, if you still need it, would be to migrate that to a different scripting host. And then what do we do if we want to mimic again our WDAG to Applocker? We bring back our WDAG wizard, and we basically just turn off script enforcement. So doing that means that suddenly everything I've explained in this slide no longer applies. PowerShell would be allowed to run, JavaScript would be allowed to run, everything would be allowed to run again, except MS-HT and MS-XML. But that does lower your security posture quite a bit, by actually 20%. So you suddenly drop down to 73% of blocked threat campaigns. So 20% of the threat campaigns out there actively abuse PowerShell and PowerShell only. So that's definitely something to keep in mind. All right, 15 minutes left. When I said that that's the biggest challenge for us, meaning we'll have to start signing our PowerShell scripts to actually allow them to run fully in your environment, which means you'll have to have a code signing script, a code signing certificate. You can buy that online. You can have your PKI to hand you one, or you can actually create it yourself. So the first line you see on the side, new self-signed certificate of the type code signing and a specific certificate and a specific subject will get you a code signing certificate on your device. You then add that certificate to your trusted store, and you can then use that to start signing code. Signing code, again, something very, very hard to do. You open PowerShell and you run the set authentic code signature commandlet with the certificate that we dynamically get from your store, and then the file that you want to trust. So the file path gives you the file that you want to trust. Running that code will sign your certificate, will sign your script. And if that certificate then is in your WDAC policy, that script will be allowed to run in full language mode like anything before. You still see the timestamp server there somewhere in between. That means that, as you all know, certificates always have a certain validity date. If you add the timestamp server and the certificate was valid at the point in time where you signed it, the script will remain valid even after the validity date has ended, since it was vetted by an external mechanism. So the script will remain trusted even after the timestamp of the validity date of your certificate had passed. So it's actually not all that hard to sign scripts. The challenge more is going to be finding out what scripts are running in your environment. So signing a script is not that hard. We actually modified VS Code a bit so that each time when we create a script and we save it, it just signs it automatically. So using VS Code, you don't actually need to do anything to have your scripts signed. Just saving them would automatically sign the script. So that brings us to how do we disable scripts in WDAC, and I've already shown you that. It's by just removing the rule or enabling the rule to disable script enforcements. Unfortunately, the wording is a bit badly chosen. You have to enable something to disable something, but that's the way it is. All right. The next one would be to allowing DLLs. And what can I say about that? Allowing DLLs in your environment to run is not a good idea. We actually...
Någonstans need to do, Martin.
Sorry, what was that?
Hi.
Someone is not muted. I'll see if I can mute him.
Okay, no,
yes.
Okay, sorry. No worries. Allowing DLLs to run in your environment is actually not a very smart thing to do. We actually do not recommend it. We even strongly discourage you to do that. And if you consider doing that, we urge you to reconsider. If you look at the code here on the right, it's just a small snippet, but it basically compiles everything here in the source code to a DLL. So that's, what is it, roughly 10, 20, 30 lines of PowerShell code to compile data or C# code to a DLL instead of an executable, and that would be allowed to run. And as I think mentioned in the beginning of the slide deck, hackers know that as well, right? All the malware guys know that as well, and the first thing they'll actually do is compile everything in DLL. I assume most of you know the Mimikatz tool. It's a very popular hacking tool that is out there. It's an executable. It equally consists entirely in PowerShell code. So there is a Mimikatz out there that only uses PowerShell code and gives you the same result. And it equally exists in a DLL version. So all of the popular malware tools are equally available in DLLs. So enabling DLLs or allowing DLLs to run is, if you want to go down the WDAC rule, not a very smart thing to do. So that would, if you would want to do that in WDAC, you can create a part rule or file rule with wildcard.dll to run. Again, don't do that. That brings us to another part where we often get the question, so how do we make then things trusted? How do we allow applications to run? And in Applocker, most of the time people use publisher rules. It's the same, you can use the same mechanism in WDAC. So if you go back again to your wizard, you go to, I want to create a publisher rule. You browse to the executable that you want to run. In our scenario, it's KeyPass, and that gives you all the things that you want to, or all the properties that you can use. So, and then you can choose your level of part rule or publisher rule that you want to use. Does it have to have a minimum version? Does it have to have an original file name? Or do we just take the publisher rule and the issuing certificate? So that's the difference in, that's one of the differences between Applocker and WDAC as well. In Applocker, you only look at the publisher certificate. In WDAC, you always take the root or the issuing CA in there as well. And we don't actually use a certificate. We use something called, or WDAC uses something called a certificate hash or the TBS hash. So once you start compiling this and you would look through your WDAC policy, you would not find that certificate in there. You would not even find the thumbprint or the serial number. It's something called the TBS hash, which is similar to a SHA-256 hash, but it just excludes certain criteria to make sure that the certificate remains trusted, even if some of the small things are modified. So it's a different bit of it's a different property that you can unfortunately not actually see on a certificate. So the TBS hash is not a property you can see on a certificate. There are tools out there that allow you to extract it, so you can then do some comparison. So that's publisher rules. And I've just showed you the how to do that in the WDAC wizard. So where are we? We're nearing the end of my time. So again, minimal Applocker implementation allows all executable or blocks only executable, allows everything to run in Windows program files x86, and allows admins to bypass every of that. Now, what does that give you if we look at the stats that we've collected from the threat analytics report? And I've already mentioned a few of these numbers during the slides. So default WDAC protects you from 93% of all of the bypasses. Adding the program file part rules doesn't change that much. If you would add Windows to that equation, the Windows part rule, you drop to 90%. If you then disable script enforcement, you drop to 73%. If you do all the part rules and scripts, you drop to 67%. If you disable DLLs, keep in mind, do that, but you then suddenly drop to 37% of effectiveness, which means that a default Applocker implementation where we just block exe and have the part rules, only 37% of all the endpoint Defender for Endpoint campaigns out there are blocked. If you compare that to a default WDAC implementation, which has 93% effectiveness, that is a very big difference. So I hope this clears a bit the difference between the two and what you can do to mimic or make Applocker easier for you by adding all of these things that, or WDAC easier by adding all of the, or disabling some of the features from WDAC by default. But do keep in mind that doing any of those scenarios drops your security posture by quite a bit. And these numbers were interesting to us as well. We kind of suspected that, we knew that, but seeing these raw numbers makes it actually very visible. So why are we not at a 100%? Well, some of the bypasses or some of the reasons why we didn't get to 100% are that two of the campaigns out there target Exchange on-prem. So if you have Exchange on-prem, depending on how well it's patched and maintained, you could use it as a WDAC bypass. So if you don't have that, and you do use only Exchange Online, your security posture raises another few percentage. Some of them target the popular Java Log4j framework, which has been in the news. I think it was last year where there was a lot of fuss about the Log4j bypass and people abusing it. So if you have the Log4j framework in one of your Java tools, and that Log4j runs with elevated credentials, that could be used as a bypass for WDAC. Again, something we could not assess before, since we don't know how your environment would be configured. Another one uses Java and malicious jar files. So if you have Java running and somebody is able to get a bad jar file on your system, that could be used as a bypass. And one of the threat campaigns is using IE11. Again, don't have IE11 anymore on your machines. So if you are not using any of the things that we have here on the screen, that would actually bring you pretty close to 100% effectiveness of WDAC. We wouldn't want to post 100% since there are some of these things that are out there. But that explains why we only took 93%, since we wanted to be more or less on the safe side and not on the very strong side. But a lot of the things in here are actually very easy to prevent. All right, so that's hopefully showed you why WDAC is worth some investment of your time and looking into. The good news is if you are using Applocker and you want to move over to WDAC, there is a tool out there released by Microsoft that is called the WDAC Toolkit that will help you converting your Applocker policies to WDAC. However, be aware of the law of conservation of misery. Your Applocker policy has probably grown organically over the past few years. You've been adding rules, you've been making applications trusted by adding publisher rules, path rules whatsoever. By just moving them over to WDAC, you keep those same rules in place. And it might be a good time to reevaluate those. Are the path rules in there still needed? Keep in mind, WDAC doesn't need path rules for program files or Windows. So we strongly encourage you to re-evaluate those path rules. Publisher rules might be a bit more challenging. You've been adding publishers for applications. Are those applications still in use? Are the versions of those applications still in use? Again, it might be worth starting over, but the tool is out there if you don't want to go through that node. But then know that you will have items in your WDAC policy that you might not be fully aware of anymore what they do. Next to that, and that's my last but one slide, there are some additional benefits in WDAC. And one of the biggest one, in our opinion, is the managed installer. So if you enable WDAC, you can enable something called the managed installer. In most scenarios, that would be your endpoint management tool, Intune, Config Manager, or even if you're using something else, which means that if you enable that for Intune or SCCM, everything written to disk by that managed installer is automatically trusted. So there is nothing you need to do to make sure that applications that you deploy through Intune or SCCM to make them trusted in WDAC. If they're written to disk by those tools and you define them as a managed installer, they'll be trusted. WDAC also has maintained recommended block rules. So there are some bypasses out there. Microsoft has a list on GitHub or on the docs page with the recommended block rules to stop those bypasses. And it's actively maintained. If a bypass is found, those block rules will be changed and modified or added. Something I mentioned in the beginning, WDAC is a security feature and Applocker is a compliance feature. So that's things to keep in mind. If you in Applocker would want to start with DLL enforcement, the first thing you do when you enable that is you get a big warning that says, hey, this might give you some performance issues. It's actually still in the docs for Applocker as well. We don't have that issue with WDAC. You also don't have it with Applocker anymore. There is no performance concern anymore. Machines these days are way fast enough to not have an issue with that. The warning is still there and people are still spooked by it. And WDAC is still actively developed versus Applocker, which is feature complete. So few more things to reconsider. Do you actually need the Windows part rules? As I said, WDAC allows everything to run for Windows, Office, Teams, OneDrive by default. So there is no need for a Windows part rule. So if you want to start adding part rules, keep in mind, do you actually want it? Again, think about the print nightmare bypass. And do you want to trust everything by Microsoft? Initially, that seems like a good idea, but Microsoft does create some interesting software as well, like the sysinternal tools. If you trust everything by Microsoft, you trust the sysinternal tools, which equally then trusts things like PSExec and so on. So are you sure you want to trust everything by Microsoft? It's just some thought or just some ideas that you might want to think about if you want to go down that route. And then my absolutely last slide. So it does take a while to properly implement WDAC. We're not here to lie about that, but the return in security posture is huge, right? You can just, in most scenarios, sit back and relax whenever something comes out and just think about whether that will affect you. Most of the time, it's not. We had a training on that September and October. That's just ended. We are starting a new WDAC training probably somewhere beginning of next year. So if you are interested in doing that, feel free to reach out to us. And it's about as hard as you want it to be. You can go the real hardcore route and block everything and not use managed installer, or you could use things like managed installer, add some path rules, and make it a bit easier to implement. So it's really up to you how challenging you want it to be.